Hello and welcome back into the RAD Mobile Developer Kickstart series from Developer Direct at Embarcadero. My name is Stephen Ball and I'm going to be taking you through this session where we're going to be exploring the framework a bit further, the FireMonkey framework that we use for mobile development within RAD Studio. And specifically we're going to get into looking at some of the samples and also explore some of the kind of core concepts that we're going to be using as we build applications on the FireMonkey framework. So today's session is the third in our series. If you are watching this on a replay, then please do go and have a look at the replays and follow your way through the series to pick up the best of everything. If you are joining us live, then please do use the Twitter and the hashtag EMBTDD, and also follow us at Embarcadero Developer Direct, EMBTD Direct. And if you've got any questions during the week, if you've got any queries that you'd like to raise with us, then please do email us on developerdirect.online@embarcadero.com, or even if you're watching this on a replay at some point in the future, then please do email us through if there's any resources you can't find, or there's anything you've seen through the series that you'd just like some further guidance with, then we'll be able to point you to the relevant resources. Feel free to email us. So let's get into the core of this lesson and exploring the framework and the samples. So over the next hour, we're going to be exploring the kind of core structures behind FireMonkey and having a look at how it's built up and how we use it. We're going to look at the concept of interfaces, and we're going to see interfaces in action through the samples, and we're going to explore those through. So we'll spend a little bit of time kind of working our way through what interfaces are and how to use them. We're also going to have a look at examples of code where we're using components, and the components are written up and they may be using interfaces behind the scenes, but we have a number of components that we're able to use that are built up from the layers within the FireMonkey framework. So with a mix of visual and non-visual components and examples, we'll be able to see how we can use those samples to build some very powerful applications with the FireMonkey framework. Now, the samples that we're going to be exploring and using through this lesson are available on SourceForge. If you go up to sourceforge.net, they're on the SVN link that's shown on the screen here. But also, if you've installed a copy of Delphie, RAD Studio or C++ Builder, then you should be able to find these examples already pre-populated into your documents folder on your local machine. So the typical path for that would be C users, public documents, RAD Studio, in this instance it's 11.0 or whatever the latest build number is for your install, and then the samples directory. Now we use SVN for the storage of these, so if you do want to just update your local copy, then you can just install a copy of an SVN client, for example Tortoise SVN, and then just literally just right click and update, and that will then pull down any additional updates and changes, any bug fixes or anything else like that to the samples, or any additional samples that have been published since you did your installation. So definitely worth just finding that folder, making sure you've got an SVN client installed, and then just updating the folder. So before we kind of explore into the framework a little bit, let's start with a little bit of an idea about what the framework's trying to achieve. Now, one of the biggest costs that we have with the way the world is changing around us is being able to make sure that we can write our code and get it onto all the devices that we need to be able to get it onto. We don't want to be writing the same code multiple times for multiple different platforms, so we have to support it in multiple different places. And because from a cost point, we then have multiple different sets of source code to manage and maintain and test. We've got multiple different sets of source code that we need engineers to work with. So we need multiple skill sets within our organization. We've got multiple IDEs that we need to learn and manage. We've got multiple frameworks that we need to learn and understand. And this dramatically increases the cost of our software development. So what the FireMonkey framework is really aiming to achieve and is doing today is about writing our code, compiling it up, and targeting it out to the different platforms that we need to get to. So that means targeting out to Windows, over to Mac, to iOS. In the future, we're working on bringing Android in as well. And beyond that, we'll look at other platforms and frameworks that are appropriate, be them smart TVs or smart watches or in-car entertainment systems or anything else like that. But the core is to have a framework that will allow us to move in the direction that we want to move as we need to move there. And it's about doing this without any virtual machines. It's about compiling out to binary code that runs directly onto the metal. And the great thing about doing this is we're not restricted to what the runtime engine or interpreters can do. We've not got a security thing to keep updated, making sure that there's no security holes within the runtime that we're working with. We're talking directly to the metal. So this, you just cannot get faster than talking in ones and zeros to the chipsets. And the reason that we're talking directly down, we're going to get a very low latency, which means we get a great user experience. Low latency is really what you're after and what people expect on devices. An example of high latency would be where you're using something like HTML or JavaScript or a scripting engine that's on the device, that's kind of using an inbuilt web browser, and then that increases the reaction time. And in fact, if you've got any internet connectivity going on, then that's going to increase the latency time as well. And we call this a high latency environment. And high latency really is unacceptable in apps. You look at the examples of Facebook, where they started off trying to write HTML code that was run through and trying to leverage that on the device to get the performance and the responses that they wanted. And Mark Zuckerberg quoted as saying HTML5 was the biggest mistake backing that Facebook have made in terms of their mobile development, which is why all their applications now are native applications. But also, you end up with a similar thing if you're using application languages that are using virtual machines within them. So if they're using just-in-time compilers or anything like that, then you still are not talking directly to the device. So you may not be able to access all the hardware or all the APIs on the local device that you can do using direct ones and zeros onto the devices. So really where you want to be for the best user experience is having low latency applications, which is what FireMonkey does. Now, part of how we do this is we use the Delphie language or the C++ language to compile into this OpenIR, which is a runtime intermediary, and that is then compiled into native ones and zeros to run out onto the different chipsets. So for years, we've had a similar tool chain for both Delphie and C++ that have enabled us to target Windows for Intel Win32, and on the Delphie side for the Win64. But with a new tool chain that was introduced a couple of years ago, we now have the ability, and the first compiler to do that was actually the C++ 64-bit compiler, which is full C++11 compliant. We use the llvm toolchain underneath, which enables us to plug multiple different compilers in and leverage out to different targets the same source code that we've got written. So this is very core to us being able to plug into different frameworks as they come through in the future. And one of the key things to being able to target out to different frameworks, as I say, is being the FireMonkey engine, how that works, and how that allows us to move across multiple platforms. Because if we think here, the Windows framework has its own APIs, it has its own set of controls, and you're going to have a label control, an edit control, and so on. A lot of similar controls, and the same ones you're going to have on Mac. But the way those controls interact with the operating system, how they're called, how they're generated, is very different from platform to platform. So to be able to get the core functionality that we want, we need to be able to do something that allows us to have access into those controls very quickly. And if you start looking at multiple platforms, then that becomes very difficult to have one code base that's working across all the frameworks. So FireMonkey's been written from the ground up to be platform independent. So we use our application language of choice to write into the FireMonkey framework, and then underneath the FireMonkey framework is then mapping out to the different platforms to enable us to go where we want to go. So our code on the top codes to FireMonkey, and then the FireMonkey framework underneath is then mapped across to Windows, to Mac, to iOS, and wherever else we go in the future. Now, the great thing about the FireMonkey framework is that a really cool example here is actually how FireMonkey is using OpenGL for Mac, it's using DirectX for Windows, it's using OpenGL ES for targeting out to the mobile platforms that we hit to. And this is the GPU language of choice on those frameworks. And FireMonkey is actually extensively using the GPU to render the controls that are displayed when you run the applications. Because to keep FireMonkey platform independent, it's actually doing all the hard work of managing those controls rather than having the operating system do them. And this enables us to actually go one step beyond with FireMonkey, where we can actually render out the same controls. They're pixel perfect for the framework because FireMonkey's framework allows us to use bitmap styles within it. And those styles are taken from each of the frameworks. So when you run out to Windows, you get the Windows look. When you run to Mac, you're going to get the Mac look. When you run to iOS, you're going to get the iOS style. When you run to wherever else we go, you're going to get a style that reflects that platform we're targeting. And this is all using the same controls and using the style engine with FireMonkey to update the look and feel of those controls. So this really does give us true portability of our code. And all of this is about being able to replicate the same code on the same on different platforms, having one easy language that we can use rather than having multiple languages, multiple frameworks. It's all just one language, one code base, one framework, one IDE, one set of file access technologies that we need to learn and work with, one set of database access components that we need to master, one set of sensors and device capabilities that we need to understand, and one set of user interface libraries and components. It's all about having the same platform, the same framework. Even the runtime library that we use, everything all the way through is exactly the same. So let's explore one of the core things that we have in here to help us along the way. And this is interfaces. Now, interfaces are a contract. An interface defines out what that contract allows you to call. And before you can use an interface, the interface needs to be implemented by a class or an object to go and do something. So if we had an interface for a steering wheel, then the steering wheel may have a turn left and turn right and so on. Now, a class must implement each method on the interface. So when you have that contract, you say, I support this contract, then you'll get an instance of the contract. So that's an instance of a class or an object that uses that interface. And you can then call the methods of that interface from the instance that you returned. And the great thing about interfaces as well is that you can implement multiple interfaces on the same object. So you could have a class that defines, let's say, a car, and you may have an interface for a door, you may have an interface for a steering wheel, you may have an interface for ignition, for starting the engine, you may have an interface for a fuel pump, or whatever it is. All of these interfaces can be used on the same object if you need it to. So you can have multiple interfaces on an object where you cannot have multiple inheritance from the same object. So interfaces are very clever and very useful at being able to implement multiple different things within the same object. So there's a great article on DocWiki introducing the implementation of interfaces, and that will be available online afterwards. And I've got a special microsite that we're just testing out that we'll give you a link to later for accessing into all the links that we show through these sessions. So let's explore an interface. I mentioned a steering wheel. Let's try and use that as an example. So we may have a steering wheel. You want to be able to turn it left, you may want to be able to turn it right, and you need to tell it how far you're turning it left and right. And you may have a current position, so it tells you where it is as a value, maybe on a 360 degrees, let's say. So let's define the contract then. So we have a steering wheel contract, and the standard for interfaces is that they start with an I. When we have a type, which are components are types, then they begin with T, and an I for an interface. So when you look at a name, you can tell pretty much straight away if it's an interface or if it's an object, type, or whatever it is. So we've got an I steering wheel here, and I've defined two procedures, one for turning left and a number of degrees, and one for turning right and a number of degrees. And then the current position which you can pass a value in. So that would be a contract for a steering wheel. Now that steering wheel contract could be used on a car, and when I'm in a car I know how to use the steering wheel, so I can turn it left, I can turn it right, and I'd expect the vehicle to respond. So when I turn it left, then the implementation of that would be to turn the wheels, and equally turning it right would turn them in the opposite direction. And when I have a current position, then that would tell me where my wheels are pointing. Now let's imagine we use the same interface but on a boat. Now a boat wouldn't have a set of wheels, it would have a rudder. So when I turn the steering wheel left, it's going to turn the rudder in one direction. When I turn the steering wheel right, it's going to turn the rudder in the opposite direction. And when I ask for the current position, it's going to tell me which direction my rudder is currently pointing. So knowing how to use a steering wheel as a driver, I can sit in a car or in a boat and know that by turning the wheel, I'd expect the vehicle to move in the direction that I need it to move as well. Now obviously a car and a boat aren't the same type of vehicles. So although they don't inherit from the same code that defines them, we can still use and ask, do you support the steering wheel interface? And if they do, we can take that and we can use it. So it's a very simple example of an interface. But let's have a look at one that we actually use within FireMonkey. So within FireMonkey, we have the ability to call the platform services. Now, I'll give you a list of some of the platform services in a moment. But with the platform services, we can ask it which interface it currently supports. And if it supports it, we can get an instance of that interface and then work with it. So for example, here's a virtual keyboard service, and this is an interface. Now part of this service is that it's going to, here we have show a virtual keyboard, and has the methods to hide a virtual keyboard. Now when it shows a virtual keyboard, it's taking in a control, which is a TFMX object, and we'll have a look at where TFMX object comes into the whole scheme of things in a moment. But basically any visual control on FlyMonkey will be a TFMX object. And also we have the ability for it to hide the virtual keyboard. So what we can do programmatically is the controls will be using these interfaces underneath, but if we want to actually call them and query them, then we can actually have a method that we say, right, let's show the keyboard. And here we're declaring up an instance of this interface. So saying I want to have a KBD service, a keyboard service, and it's going to be the iFMX keyboard service interface. And then at runtime, we're able to ask the platform services of what's currently supported. Can it support the platform service iFMX keyboard service, virtual keyboard service? And then we pass a pointer to the keyboard service locally. So if it supports it, it will return true. If it doesn't, it will return false. So if it does support it, then we're able to use it. So we're then able to say, right, taking this contract, I want you to go and show the virtual keyboard and pass in the object that we want it to work on. So that will then go ahead and show the virtual keyboard for the form. Now the great thing here is we can use the same code on Windows, on Mac, on iOS. If it supports a virtual keyboard, then it will return back and it will show the virtual keyboard. I don't have to worry about what the platform is, and indeed the instance of the interface that's returned here on iOS, it will be an iOS virtual keyboard service that's returned. If it's on Android in the future, it'll be an Android virtual keyboard service. If it's on Windows, on maybe a slab device where it supports the virtual keyboard, then it will be a Windows virtual keyboard service object that's returned. Now the implementation of those objects may be very different underneath because they're talking to the actual specific platform we're targeting. But in terms of what we need to do within the code, we code to the interface, and that allows our code to work across multiple platforms very easily. So there's a number of core services that are there available for us straight away. Application services, the Windows service, the timer service, the dialog service, canvas service, the context service, the menu service, and the locale service. Now, most of these are declared in the fmx.platform unit, so if you ever want to go find them, just go ahead and open up that unit of code, and you can go and explore in there and see what interfaces are defined, and it will tell you the contracts that they hold, and then you'll be able to go ahead and, using what we've just learned here, code to them at runtime. Okay, so let's go and explore a couple of these interfaces working, and then we'll come back and we'll have a look at some further stuff around gestures and also around some of the components that we have available. But let's just finish off our interface section first. Okay, so let's go find the samples. So I'm just going to go File and Open Project, and if we go to the Documents folder, Raj Studio, 11 samples. We can see here I've got some green ticks and some red exclamation marks where things have either been changed or might be out of date on the repo. So if you have got an SVN client, then obviously you can just right click and update those. So let's go ahead and explore through what we have here in the samples directory. There's a number of C++ examples in here. There's some samples database which we'll be looking at in lesson 4. There's a few datasnap examples which we may have a look at later in the series, but we've got quite a few datasnap bits to get through, but they're there as well. There's a number of Delphie examples in here with the runtime language and VCL and some specific cloud API and COM and other stuff in there. There's some FireMonkey and FireMonkey iOS, and then the iOS code snippets. And they're probably the three that you want to kind of get to know the most because they'll really help you through with getting ready for mobile, especially the second two, the FireMonkey Mobile and the iOS code snippets. Now in the iOS code snippets folder, there's a whole load of different examples of doing things, being it using the web browser, being it using the camera component, be it accessing the camera roll, be it using IB Lite, which we'll have a look at next week. So if you want to get ahead, then go ahead and have a look at the samples in here. We'll also have code in here for accessing the accelerometer. So this is an example of a non-visual component with the accelerometer. So let's go and have a look at the keyboard. Now, I think we have in the FireMonkey Mobile here, we have a keyboard toolbar example. So I'm just going to open this up. And in here we can see we've got, this is a list box, and the list box has got a group header that's been added into it. And we can see this has got the transparent style set to it, so, and it's set to grouped. So we have a look here under the style lookup. Remember we talk about the style lookups in previous lessons, so that's applying that kind of transparent style, and the fact that the list box has been grouped allows us to then see kind of the rounded corners on the top item and the bottom item within there. So if you're looking for the grouped property, then that is on the object inspector. It helps if I choose the list box. So what I did there is if you select any control that's within it and hit escape, it'll come up to the actual main control. So we can see here the grouped kind is that it's grouped, and the style is the transparent list box style. Okay, so let's have a quick look at the code underneath here before we go and run the application. So we can see here we've got an instance of an interface, the iFMX Virtual Keyboard Toolbar service. So that is implemented. We're going to have a look in the form create. Again, Control Shift down arrow will move you down from the interface to the implementation part of the code. So here we're asking the platform services for the current platform. Do you support the platform service iFMX Virtual Keyboard Toolbar service? And that is then passing in the service that's defined on the class of the form. And if it does, then it goes ahead and sets the is checked property of the toolbar and the done button to the is toolbar enabled and is hide virtual button visible, which are methods or properties of the interface. So in fact, let's go ahead and we can drill down. If we just control click on here, find declaration, that'll take us to the declaration. We can then control click and find declaration of the interface, and that'll take us down to the FMX virtual keyboard. And here we can see the virtual keyboard interface. We can see the virtual keyboard service. We can also see here now we've got the virtual keyboard toolbar service, which is what we're working with. And this has methods for adding buttons, deleting buttons, getting the button count, and then getting the button by index, and clearing buttons. So we can clearly add to the virtual keyboard a number of buttons get the number of buttons and return a button by its instance. And that's going to return a T virtual keyboard tool button, and there's a method of that here. So let's go ahead and have a look, see what we're actually going to do with fservice through this code. So we're using it in a button add click. So on the form here, we can see we've got the add button. And if we select the events here, we can see there's an on click button. So we've got if assigned, and it's asking the input query to be shown. So that will give us a boolean if it's accepted, or a cancel if it's not. So if it's accepted, then that will add as a true. So add new toolbar is, or tool button is the caption, and then the prompt is enter button caption, and then it takes an array. And so it's just a string here, which is L caption, and the caption is not empty. So here we're using some extended class method, class helpers that have been put onto the strings. Let's just do L caption. Let's just choose compare, and we can go find the declaration for that. And that's on the string helper, which is in sysutils. So this string helper, which is a record helper for a string, gives us all these methods that we can then call on a string across multiple platforms. So this is a very useful thing. I'm not really kind of planning to focus on that today, but I just wanted to show you where that was. So let's just get it out of the way. So anyway, we were checking here if we've got a value added in, then we're going to literally add we're going to add the caption to the list box buttons, which we've got here, which just tells us which ones we've got. And then we're going to use the service to add the button to the virtual keyboard. And we're going to pass a custom button execute method. So the add button has a string plus a tNotify event that's used. So the custom button execute, let's just go find that. We can see here we just defined a tNotify event. So a tNotify event is a procedure with a sender of a T object. And we can then define that and then just pass a pointer to that. So when this button name is clicked on, it's going to fire this event here. And then we've got the delete method here, which will go ahead and check the list box that it's got a selected item. And if the service is assigned, then it's going to ask it to delete the selected item index from the list of buttons. And it's using -1 here because of the group header. Okay, nice little note in code there. So, and then, yeah, it'll remove it from the list box. So it's some pretty simple code. Let's just go ahead and run this out to the simulator. So if we click in here, we can now turn the done button on and off using the interface. In fact, we could kind of take the toolbar off as well if we wanted to. But let's just pop it back on. Let's go ahead and add a button, and we'll do hello. And let's add another one for world. And if we click in here now, we can see we've got additional buttons, and that's going to say you've clicked on hello, you've clicked on world. And let's just go ahead and delete one, and we can now see we've just got the hello there. So this is just showing how you can use the interface. We don't create the virtual keyboard or anything itself. We're just saying give us the handle to that interface with the contract that it supports and using the interface. So let's now have a quick look at the gestures. Now there's a lot we can do with gestures. We can swipe, we can tap, we can pinch and zoom, we can tap and hold, and we can get notification of when those events happen. Now there's some samples in the applications, in the samples folder that shows us how to use the gestures, but let's just go in and have a quick play with those ourselves. So I'm just going to go create a blank FireMonkey application here. Now on the form, if we scroll down, we can see there's this touch property, which I've just got expanded out here. Now the touch property has, it says here we need to assign a gesture manager, so let's just go and do that first. Now once we've got our gesture manager assigned, we can see we've got a number of standard gestures that we can use on iOS. Now we've got left and right and up and down and up and left and up and right and so on. So you can code to all of these. Circles, semicircles, a whole load of different things. And there's also a number of interactive gestures. So zooming, panning, rotation, a two-finger tap, a press and tap, double tap, and a long tap. So each of these gestures, when they're fired, will fire an event, an on-gesture event. So if we go to the form where we've hooked up the gesture manager and go to the on-gesture event, in here we can come and code that when a gesture happens, what we want to do. Now the first thing is we get event information here, which is a T-gesture event info. So press the control key, hold the mouse over it, select and find declaration. And this gives us here a gesture event info, which is a record which includes the gesture ID, a location, which is a T point, so where on the screen that the gesture has been done, any interactive gesture flags that we need to be aware of, the angle, the inertia vector, the distance, and the tap location. So all of these bits, depending on what gesture we're running, will actually give us the information that we need to know. So the interactive gesture flags are either begin, inertia, or end. And you can see that the flags is a set of these flags. So you can have any one of these three within this set. So let's go have a look at the gesture ID. Now the gesture ID is from RGI first to RGI last. So let's just select the first one, and we can see here this is first to last, which is this is the range, and these are registered custom gesture ID ranges. But if we actually have a look above here, we can see all the IDs, the standard gesture IDs. So no gesture is 0. Left, right, up, down, up, left, up, right, and so on. All these SGI constants, standard gesture information constant, they're all part of system.ui types. So you can come in here and you can say, right, I want to do, if somebody does a triangle, so I can select that, and I can say in here, if event info dot gesture ID equals a triangle event, then show message triangle. So that's as simple as you need to do to code to those gestures. But let's actually have a look at some of the predefined samples. So if we go File, Open Project, and it's here in the Samples, iOS Code Snippets, iOS Interactive Gestures. There's 3 different folders here with some samples in already. So I'm just going to use the tap and hold because I can demo that one on the simulator. So we can see here the form's got its gesture manager. It's checking if it's a tap, if it's the long tap, then which is the tap and hold. We're then going to show a message, tap and hold detected at, and it's then going to use the event location to show us where on the screen the tap was made. So that's all the code that's in there. just that one method that's been implemented. We can see here we've got the gesture manager on the form, and if we go back to the form and look down here, we can see here we've just got the long tap interactive gesture is the only one that we're interested in here. So let's pop to our simulator and see that running. So let's just do a tap and hold there, and maybe over here. You can see the values have gone up. Let's try and click on the sun, and you can see the kind of the X and the Y values changing there. So very, very simple to use the gestures within our applications. Okay, so let's move on now and have a look at our next example. We're going to have a look at the notification center. Okay, so the notification center allows us to send scheduled notifications. It allows us to present a local notification immediately. It allows us to cancel all notifications, cancel specified scheduled local notifications. It allows us to set badge numbers for application icons. It allows us to reset badge numbers for the application icons. So the key basic notification or alerts styles here are the ones that we can see on the screen. And we either get a badge or an application icon. We get the notification banner on the iPad. We get the notification alert and the notification center on the iPad. So let's have a look at the notification center interface in action. So I'm going to go and open project. I'm going to go to our samples directory, and this one's in the iOS code snippets, iOS notifications, and in fact if we go ahead and have a look in here, we can see there's two notification examples in here, one for sending and cancelling notifications, and notifications are those little messages that pop up on your phone saying meeting in 15 minutes or something like that. So you can use the notification center for that kind of thing. But also we can set the badge, so the little number that sits on the icon for the application, we can set that with the badge number example. So let's go ahead and open this up. And these are all using the same interface. So let's scroll down here. We can see here we're asking for the llvm notification center. So let's this is our declaration there. So let's just go ahead and find that. And we can see here that this interface works with notification center in Apple's platforms. So if it's on Windows or on Mac, if it's on Mac or on iOS, then the notification center is there. And we can then schedule notification, present notification, cancel notification, cancel all notifications. We can set the icon badge number, or we can reset the icon badge number. So the example that we're looking at here is asking if the platform we're running on supports notification center. If it does, then great, we're going to get an instance of the notification center back. We'll then be able to set the icon badge number because that's a method on the notification interface. So here we can set the badge number and we pass in the value that we want the badge number to be set to. And then just the other code here is just incrementing and decreasing the value for the badge number on the screen. And then the reset, which just sets it back to 0. Okay, so let's go ahead and run this. And just minimize this out of the way. There we are. So here we can go ahead, let's change this to 42, which is obviously the best value you should set the badge number to. And go and set that. And if we leave our application here, we can see that's set to 42. So let's set it up to, let's say, 30. And we can now see that's set to 30. So setting the badge number is very easy to do using the interface. So the one thing I love about coding to the interfaces here is that as soon as we know what we want to do, our code can use the interface, and if there's any changes for different platforms in the future, but that platform supports the interface, then great. We just go ahead and leave our code as it is, and it will go ahead and support that. And the nice thing as well is when we're working with multiple different types of devices, so you could have an iPod Touch, you could have an iPhone, an iPad, you could have a Mac, you could have a Windows machine, or wherever. Each of these different devices has different methods and capabilities. So for example, with the telephone interface that allows you to ring a telephone number, you wouldn't be able to do that on an iPod or an iPod Touch. So that interface will not be supported there. But our code can still work the same, and if it's added to the App Store, they can go ahead and use it on an iPhone device. But when it gets to the iPod Touch, then you can list the telephone number, but you can't allow them to call it, for example. So it's great being able to code to the interfaces and to find out with those what the device supports. Okay, so along with the interfaces, which are great for working in code, sometimes you want to be able to do things on the form and use some of the non-visual components. So example here is the orientation sensor. This is a non-visual component. You can get to it in code, but there's methods there that allow, or events that allow you to find out when it's been tilted, what the distance between the values and so on is as well. So if you wanted to build a compass, then this would be the component to go ahead and use. There's examples for that within the samples directory. Also the motion sensor, which is the accelerometer. This is used to detect motion in your application as you move your iOS device around. So you can detect the X, Y and the Z coordinates being changed. And you can use this to determine speed and motion through your application. So if you're wanting to track how fast people are moving, where they're moving from, then you can use the motion sensor. So if you were you wanted to move a control from the left to the right of the screen via them tilting the device, then you could go ahead and do that with this. We also have components for location sensors. Now the location sensor has all the abilities built in there to return back the latitude and longitude. It uses reverse geocoding to convert location data to readable addresses, and this works across Windows, Mac and iOS. And it can be used with the web browser component to display the location on a map. You can update for example, a call to your favourite mapping engine, be it Google Maps or Open Street View or anything else like that. And you can then, obviously, when you get a notification of a latitude longitude change, you can ask the map to go redraw itself to the new coordinates. And yeah, this is a great component for being able to track where you're at. But one of the other things that you can do with it is it goes through a number of different states as it's setting up, and you can track those state changes because with any application on an iOS device, it's going to be asking for permission to allow the application to have that data. So the user is always in control of their data. So at the point it's going through that authorization process and it pops up the message at the start saying, would you like to allow this application to access your location coordinates? Then you'll get notification of where it is through that process within your code as well. Now, one other example of a physical non-visual component we have is the camera component, and this allows you to get access to the device camera. It allows you to activate the flash on the camera. You're able to get information back about the device, if it's got a front camera or a back camera, and so on. Also with the camera you can capture images and also get the sensor position as well. So let's finish off by having a look through a couple of those controls and those components. So I'm going to go, let's go and open up our samples again. And here we've got the camera component. Let's go ahead and have a look at that one. So here we can ask to start the camera, stop the camera. We can get the front and the back image. We can find out if we can turn the camera flash on, off or auto. And we've got the actual camera component here. And we can see there's an on sample buffer ready. So basically as the camera's running, it's then going to get the image that's passed through, and it's going to update the image camera view, which is the image on the screen, with the camera view bitmap width. So let's have a quick look. Get image here is just asking it to get the camera's sample buffer to bitmap. Here we're also able to ask, does the camera have a flash? So obviously it's not something you can set in code because you don't know if the camera's going to have a flash, but you can query it at runtime. Likewise, you can ask the camera what type of kind it is, so it's T camera kind. And here if we go find the T camera kind, we can see default front camera or back camera. And these were part of the fmx.media unit. Okay, so let's, I won't run that one because otherwise I need to hook up my device. But let's go and have a look at a couple of the others. So in the iOS code snippets here, we've got the accelerometer one. So let's go and open that. Now we've got our motion sensor here, which has got on data changed, on sensor choosing, on sensor removed, on state changed. So we can use those on the data changed event here if we wanted to. But we've actually just got a timer that's just running. When the switch is switched over, we just set the motion sensor active or inactive and the timer to match. And then the timer is just running through, and we're running this every 50 milliseconds. It's just looping through and it's checking each of the properties, and it's then just updating the screen to say what the value is. So pretty simple code here, and I'm going to try and run this out to my device, so let me just plug that in. Okay, so that's plugged in and unlocked, so let's just go ahead and run. So it's now going to link it, deploy it across to my device. It's got to sign it on the iOS on the machine as well. So let's just shoot over here. We should now be able to see my application open up. So let's just turn this on, and we can see the different properties that I have available to me here, showing as I move the device around. We'll see the numbers changing. Okay, so I think that brings us nicely near the end of our time today. So let's just jump back to our slides just to finish off here. So our next lesson we're going to be looking into local storage, and we're going to be exploring how we can access into local storage, how we can get files across to the device to use as well. We'll be having a look at some database activity and some kind of local alternatives to using databases as well, if we just need to store a couple of values and so on, like ini files and data sets and so on. And then we'll build on in our final two sessions, looking obviously at SOAP and JSON servers, and also then finally data snap and how we can really leverage the power of that. Now, as always, streaming.embarcadero.com to get hold of the replays, and do keep an eye on that website. We've got some pretty fun stuff that's just coming up there for you, where you can go and look at the different lessons, find the resource links. They're all going to be posted up there in a nice organised manner for you to play around with as part of a micro beta site that we're just trying out. So do have a look at that. So before we just finish off with Q&A, actually there's one thing I just want a resource from a webinar that was run this week by Pavel Glowacki, who's our European technical lead for Delphie. And he did a RAD in Action FireMonkey multiple device webinar. So you may want to go and register up for that so you can get a link to the replay, which is quite useful. There's also a great FireMonkey in-depth components and styles white paper, which is kind of 30 plus pages by Marco Cantu. And very cool, there's this PDF which you can download and print out, which is the FireMonkey component framework. So it takes you through the hierarchy and starts off with TFMX object, which is really the base root of any FireMonkey control. T component, you can use T component for the non-visual components, but if you want it to be visual, then you're going to be using TFMX object. And it then explores the different areas that TFMX object touches around the animations, around the effects, and also then down here through the graphical primitives, which are used to build up the styled controls and the styled 3D controls. So it's a very, very useful overview of the FireMonkey framework and the different sections within it. If you want to explore more around the animations and the effects and how the graphical primitives all come together with the styled controls and everything, then please do have a look at some of the developer direct replays that are linked up on the streaming.embarcadero.com. There's some excellent sessions that we've gone through the whole FireMonkey framework at a more in-depth level than we're covering today. But do kind of deduct in for that, or even better, just watch Pavel's replay of the webinar. So really it is now time for some Q&A.